What if I told you that space isn't what you think it is? That out there, beyond the veil of observable reality, are secrets so bizarre, so unsettling, that even NASA won't officially talk about them. This isn't just fringe science or conspiracy. These are real theoretical breakthroughs that threaten to shatter the very fabric of physics as we know it. Welcome to the forbidden theories of space, the anomalies, the banned concepts, and the cosmic whispers too dangerous to become mainstream. From white holes to tachyons and repulsive gravity fields to alternate dimensions, get ready to dive into the ideas that science fears. The unseen gateways, white holes, and the other side of reality. Imagine a cosmic gate that nothing can enter, only escape. A portal where time runs in reverse and matter spews out instead of being pulled in. That's the white hole, the hypothetical twin of a black hole, predicted by Einstein's field equations but shrouded in mystery. Unlike black holes, which trap everything, even light, white holes are said to do the opposite. They're regions where nothing can enter, but matter and light erupt outward uncontrollably. These aren't science fiction constructs, they're mathematical possibilities, born from the same equations that proved black holes exist. And yet, no one talks about them. Why? Because white holes break the laws of causality. They suggest that something could emerge from nothing, violating thermodynamics and the idea of a closed system. If black holes are endpoints, cosmic dead ends, white holes are beginnings, possibly even the birthplaces of new universes. Some fringe theorists argue that the Big Bang itself was a white hole. Others believe that every black hole might be connected to a white hole in another region of space or even another universe, creating a wormhole, a cosmic shortcut through space-time. But here's the kicker, we've never observed one. Not directly, and if they exist, they may last only fractions of a second, vanishing before our instruments can catch them. Or they may lie at the heart of our universe's greatest mysteries, hiding in plain sight. In 2006, astronomers detected an unusual gamma-ray burst, an event that didn't match typical black hole or neutron star behavior. Some believe it could have been the first indirect sign of a white hole. The resistance to white holes isn't just scientific, it's philosophical. Accepting their existence would mean rewriting the fundamental narrative of physics. That all events have causes, that entropy always increases, and that the universe is a closed loop of decay. White holes flip that script. They imply regeneration, rebirth, even escape routes from annihilation. Why doesn't NASA talk about them? Because the evidence is murky, and the implications are enormous. White holes would force us to confront the idea that death is not final, that black holes aren't the end of information, and that the universe might be littered with cosmic backdoors to other realities. Whether they're real or not, the very possibility of white holes challenges our deepest assumptions about space, time, and existence itself. Tachyons, the speed limit breakers of the universe. What if I told you that not everything in the universe is bound by the speed of light? That there might be particles out there, tachyons, that don't just challenge Einstein's rules. They ignore them completely. According to special relativity, nothing with mass can travel faster than light. But tachyons? They start above that limit. Born faster than light, they can never slow down, only speed up, forever beyond our reach and beyond our understanding. Tachyons were first proposed in the 1960s as a purely theoretical possibility. They don't fit into our standard model, but they slip into the math in curious ways, especially in equations that describe quantum fields and string theory. And while no one's ever observed a tachyon, their implications are staggering. If they exist, they could be the key to quantum communication across galaxies. They could transmit information backward in time. Let that sink in, backward in time. A message sent today could be received yesterday. But here's the catch, if tachyons exist, they tear apart everything we know about causality. Imagine killing your own grandfather before your parent was born. That's the kind of time paradox tachyons create. It's why mainstream science avoids them like a plague. Not because they're impossible, but because they're too possible. They break logic, they break chronology, and they break science as we know it. Tachyons also raise troubling questions about free will and determinism. If information can flow backward through time, are we truly making choices? Or are our futures already influencing our present? Could some of the strange quantum effects we observe, like particles being entangled across space and time, be echoes of tachyon activity? Some fringe physicists think so. And here's where it gets even weirder. In 2011, scientists at CERN thought they might have detected particles moving faster than light, neutrinos arriving earlier than expected. The world held its breath. Had tachyons finally shown themselves? Sadly, it turned out to be a faulty cable. But for a brief moment, the world of physics was on fire. NASA doesn't explore tachyons publicly, and most institutions don't mention them beyond mathematical curiosity. But the concept hasn't disappeared. In classified labs and theoretical physics circles, the question lingers: what if the speed of light isn't the final word? What if the universe has hidden highways, tachyonic tunnels through space-time that could connect distant galaxies, or even separate moments in time? In the next chapter, we'll take this even further, into the realm of dark energy and galaxies that repel instead of attract. Prepare yourself for a force more mysterious than gravity. Anti-gravity on a cosmic scale. Galaxies that repel, the anti-gravity enigma. Picture this: galaxies not pulling each other closer through gravity, but pushing each other apart with an unseen force. Not just drifting, but accelerating, repelled across the fabric of space like magnets with the same charge. Sounds impossible? Welcome to the most mind-bending chapter of modern cosmology, where galaxies don't just defy gravity, they appear to escape its grip entirely. This isn't speculation. This is observation. In 1998, two separate teams of astronomers, studying distant supernovae, discovered something shocking. The universe isn't just expanding, it's accelerating. That single discovery flipped our understanding of the cosmos upside down. To explain this, scientists proposed dark energy, a mysterious, invisible force that makes up nearly 70% of the entire universe. But what if we've misunderstood it completely? What if it's not energy pushing space outward, but entire galaxies generating repulsion, something akin to anti-gravity? Some researchers believe this might be possible through negative mass, hypothetical matter that moves opposite to applied force. If you pushed it, it would come toward you. Put enough of it in a galaxy, and it might cause that galaxy to repel everything around it. Now here's the terrifying part. These repelling galaxies could be real, and we might already be surrounded by them. There are regions of the universe, like the mysterious cold spot in the cosmic microwave background, that behave strangely, as if entire swaths of space are being pushed away by something unseen. We call them voids. But what if they're repelling galaxies cloaked in negative mass? Mainstream science treats negative mass as speculative, even absurd. But alternative models of physics, including some versions of modified gravity and quantum field theory, suggest it could be possible. And if even one galaxy out there contains this exotic matter, it could change everything. Galaxies that repel mass, the cosmic rebels. Imagine a galaxy so strange, so unthinkable, that instead of pulling matter toward it like every star, black hole, or planet we know, it pushes matter away. These are not fantasy creations from a sci-fi movie. They are theoretical anomalies that shake the very core of physics. Welcome to the enigma of repulsive galaxies, cosmic structures that defy gravity as we know it. Traditional physics tells us gravity is always attractive. It pulls apples to the ground, binds the Earth to the sun, and keeps galaxies together. But some new hypotheses suggest the existence of exotic forms of matter, or even entirely unknown forces that could generate repulsive gravitational effects. These aren't just wild ideas tossed around in late-night Reddit threads. Mathematically, they emerge in certain solutions of Einstein's field equations under extreme conditions, particularly when discussing negative mass or dark energy concentrations. Negative mass, if it exists, would behave in completely mind-bending ways. When pushed, it would accelerate toward you. When near a normal mass, it would move away while pulling the normal mass along with it. That means if a galaxy were made of or surrounded by a halo of negative mass, it would appear to repel normal matter and light. And here's where it gets truly disturbing. Astronomers have already detected strange voids in the cosmos, enormous regions where galaxies seem to accelerate outward unnaturally, away from a central point, not pulled by anything visible, but seemingly pushed. Some speculate these voids might be surrounded by negative mass halos or something we can't yet measure, dark energy in local concentration, forming repulsive gravity wells. Could these be galaxies that repel instead of attract? Could they be pockets of the universe rejecting the fundamental rules we take for granted? The mainstream response is silence or dismissal. Because if true, these discoveries would force a rewrite of our deepest laws of motion, gravity, and cosmology. It would suggest that not only is the universe expanding, it's also tearing itself apart from within, with phantom galaxies pushing matter out of their way like invisible anti-gravity engines. And NASA? Silent. Because confirming such a thing would not only wreck current models but also open terrifying possibilities about our universe's future. Where repelling galaxies dominate, collapse becomes impossible, and the cosmos stretches into chaos. But the question remains, are we witnessing glitches in observation? Or has the universe been screaming a deeper truth we're too afraid to hear? A truth where repulsion, not attraction, is the key to the next era of physics.